This question wants us to differentiate a sine inverse of cosine of x. So there are two ways we can do this. We could do this with implicit differentiation by moving the sign over and getting sine of y. So, if we write out let y equals to sine inverse of cosine of x, I could write, if I wanted to, sine of y equals to cosine of x, and then do implicit differentiation. Alternatively, we now know how to differentiate inverse trigonometric functions. So I could just differentiate this one directly. So dy by dx is equal to 1 over the square root of 1 minus cosine squared of x, and then times the derivative of this mess, because of the chain rule, which is negative sine of x. So that's pretty cool, because now if I look at this expression here in the denominator, the square root of 1 minus cosine squared of x, well, 1 minus cosine squared of x is sine squared of x. So if I take the square root, it's easy enough to see what I'm going to get, right? So actually what I end up with, there's a little trick here, but I end up with negative sine of x over the absolute value of sine of x, and this is going to be equal to either negative 1 or 1, depending on whether sine x is positive or negative. Now, by right, we shouldn't be lazy and write this. We should instead tell our examiner that sine x is positive, the area in which sine of x is positive, and the area in which sine of x is negative. But of course these are infinite areas, there's an infinite number of intervals, so we get a little bit lazy and we just leave it written like that. So this is my final answer.